Good morning, everyone. Thanks for coming. My name is Jimmy Bogard. That's my Twitter or X handle. I don't know. Is it still up? I don't know. I guess it's still up these days, Twitter. So you can find me there still, I guess, but mainly these days, I guess, other places. You can find this presentation and all the code associated with it on my GitHub at github.com/jbogard. There's a presentations repository there. And my day job is a software consultant. And so this talk has really been like the last 12 to 18 months of my life of doing this .NET migration, initially from .NET 4.8 to .NET to .NET 6, and now to .NET 7. And I guess next week, I'll have to retitle this to .NET 8. But there's not a whole lot that's changed between .NET 6 and .NET 7 in terms of the migration strategies. And so when I do come up with those different things, I'll go ahead and highlight them. Most people know me from open source stuff, so I have a couple libraries people use, AutoMapper and Mediator, so you're welcome or I'm sorry. It's usually one of those two buckets. So let's get started. So this talk is from a project for the past 12 months or so, in which a fairly large existing application, they needed to migrate from .NET 4.8 to .NET 6 and eventually to .NET 7. Now, in the past, this was a pretty challenging thing to do. It was really difficult to try to incrementally migrate from one application to the other. It was definitely possible, so I've done this with .NET Core 2 and .NET Core 3.1. But starting with .NET 6, it became much, much easier to do this sort of incremental migration for certain things that we want to migrate. And so I'm from Texas, and we see this kind of migration strategy quite a bit of a incremental migration where I'm slowly migrating one piece at a time from one point to the next, because we build a lot of these things, of these highways. And one of the things I notice when they're building these highways in Texas is they never just build an entirely new highway off to the side and then just one day all the traffic just switches over from one old highway to the new one. Instead of this, it's this very incremental addition to the existing highway. Along the way, it's pretty messy. There's a lot of messiness in doing this construction and trying to slowly build a new highway alongside the existing one. And so as we're migrating, it may look a little ugly. There may be some shims, some things we're trying to just put in place temporarily while we're doing this migration with the hope that we take them out later. And so we see this in highway migrations as well, where they'll go from the new highway to the old one, and it's really bumpy during that transition. But eventually, the old road is gone, and the new road is there, and none of the old road exists anymore. But during that time period, it can look a little ugly. So just some history of .NET. I got this online somewhere. This is one of the hard things I have to do to explain to business folks about why we need to do this migration, because they're like, why is this such a hard thing? We had .NET framework starting, 20 years ago now. Shouldn't it be easy for us to go from .NET 4.5 to .NET 5? I was like, no, that's just the marketing department that made it seem like it was going to be super easy to switch from one to the other. Actually, let's zoom in about it because this is hard to read. There we go, much better. So we had this transition period where while the .NET framework was still kind of going along, there's this new .NET thing going on with .NET Core. And eventually they decided, okay, we got to the point where we need to go to .NET Core 4, but that would be too confusing with .NET Framework 4. So instead, we'll just scrap the whole name of .NET Framework and call it .NET 5, and then everyone knew exactly what everyone was talking about, right? No, this is still pretty confusing, but this talk will be about going to .NET 6 and .NET 7 there at the end. So .NET Framework, though, is dead as a framework. There are going to be no more additions to it anymore. So it's something that will be supported by Microsoft. They don't even have an end date anymore. I think they tried to put an end date of next year, and everyone revolted, and they said, okay, how about it will never be out of support. We just won't actually do anything to improve it ever again. So it's just going to sit there forever, I guess. And so for teams and companies that are sitting on these big .NET framework applications, they're looking to understand, well, how do we then continue to evolve our systems going forward? Now, if you have an application that doesn't need a change and is sitting on .NET Framework 4.8, you don't need to migrate it. You can just let it sit there if it's doing its job and it doesn't need to be upgraded. But if you're still wanting to if you still are wanting to continue to evolve that application and grow it over time, what we found out is that a lot of our dependencies and things we were using no longer were being updated for the old framework. So it really was a business necessity for us to move from .NET Framework 4.8 to .NET 6. So yeah, the first thing that we were doing for this client was just to understand how hard is this going to be for us to migrate from .NET Framework 4.8 to .NET 6 and .NET 7. So for us, that starts with cataloging and understanding what is there, what are the different components and pieces and dependencies, and are there migration paths for each of these different components. So this application had MVC web endpoints. So these are things that returned HTML, or API like JSON sort of things. So this had both MVC and API controllers and actions. It also had non-MVC HTTP endpoints. So these are things that were still returning HTML, but not like the good model view controller way of doing things, but like the really old crusty ASPX pages, the things that I try to forget that ever existed, but then I see these old applications and then oh god, I forgot that these things were a thing. So those existed as well. There's quite a bit of middleware, so things that were hooking into the MVC pipeline. So these are things like action filters, validation filters, things like that. And there's also, at the core ASP.NET level, there's also middleware there. So loading up that web config file, that horrible XML stuff, and seeing there's some stuff in there as well. We're also cataloging library dependencies and component dependencies. So what are the things outside of the application and outside of the core framework does our application use? Okay, so I'm going to be highlighting the sample application that's using ASP.NET MVC5 with Razor. So this is kind of the easy mode of the migration. It's also using SignalR. It's using session states. It's using Hangfire for background tasks. And it was more or less the state-of-the-art circa 2010. So if you imagine the kinds of things like onion architecture or clean architecture, it's doing all that sort of junk that we would see back in 2010. So from the get-go, I want to understand just how big is this application, and for us in terms of our migration process, we wanted to do more or less kind of one screen at a time. That's kind of hard with controllers and actions, so really want to say we'll do one controller at a time because it's basically one file. I can say, okay, this entire file is migrated over here with the previous style of MVC to the new style of MVC and everything else that went with it. So the first thing we did was just try to get an inventory of the controllers and actions. So this is just reflection code that says, let me go load up all the controllers and actions, the types, and just iterate through them and print them out on the screen, and then tells me how many controllers there are, how many actions are in each controller, and then we also wanted to understand what would be the level of complexity of migrating one given controller or action, mainly because we wanted to know from a kind of planning perspective, what's a good place to start. And we probably didn't want to start with the hardest one, like the thing that had the most actions or the most dependencies or the biggest screens or whatever. So for this gave us a printout of just how much stuff is going on. So in my sample application, I printed this out. They told me I've got 6 controllers here, and there's 58 actions, and then some of the controllers are more complicated than others. So we can see over here that's the last controller there, the account controller, which is doing security stuff, has 22 actions. So that's going to be more complicated to do than one with fewer actions. So if I'm looking at a place to start, I'm probably going to start with the one with the least number of actions or pages, and also the least number of constructor arguments, because that also tells me how much stuff is it reaching out to do in the rest of the application. So we also wanted to understand the middleware associated with this. So from an MVC perspective, this is us going and looking into the various places in ASP.NET MVC5 where you can hook those sort of things up. So here I've got the application start and the global ASAX. And again, going back to these applications just brings back these kind of horrible memories of how hard it was to hook all these sort of things up in the older framework. And so I'm trying to understand here what kind of things is it doing on every single request. So here I can see that it's got some filters it's registering, so that's going to be some place also I'll look to do. It's got some entity framework junk, and so I have to worry about how to migrate that stuff. And then it also looks like it's doing doing a custom view engine, because that was the thing we did back in those days. In this case, it's doing a feature folder view engine, so the views are not located in a views folder. They're actually located in a kind of feature folder sort of thing. Do a lot these days, but was more difficult to do back in those days. Okay, so the filters. What do we have in here? Nothing too exciting. I've got something that handles errors, so probably some kind of global, if I get an exception somewhere, show a custom page. I've got a validator filter, so something that's validating all the form inputs in one place. And then there's a transaction filter that around every single post request, it does a database transaction, as opposed to having it explicitly in each one. So I could dig in each one of those, but each one of those is doing fairly simple stuff. And so those will be somewhat straightforward for us to migrate. In our real application that I was dealing with for the clients, it had like 12 filters in there, and they were more complicated. And so for each one of those, we had to decide, are we going to port this behavior over, or is there like a better way of doing each of these kinds of actions, or each of these kinds of cross-cutting concerns in the new framework? One of the things we wanted to avoid was just kind of blindly pulling all the code over without really thinking about, is there a better way of doing each of this? But we also had a balance of saying, we don't want to re-architect the entire system as we go, because then this could take forever of migrating. So we were trying to balance like making it better as we go versus just pulling it over as is. We also had Owen. Does everyone remember that? Owen? Yes. I forgot about this. Like I had just like completely flushed it out of my brain. And then you see these applications like, oh right, well, there's so many arguments about this other new way of doing application hosts and servers and stuff. And then it just went away with ASP.NET Core. But for these old applications, they still exist. And so we have to worry about, okay, well, we can, like Owen actually does exist in ASP.NET Core, but we probably shouldn't use it, because it's like a completely separate way of doing applications and middleware versus the built-in way. And so for each of these, I'll look at, well, what is like the new right way of doing things? But here I can see that it's got SignalR is pulled in this way. So it's got doing some background push notifications up to the client. And then I also see it's doing Hangfire. Hangfire, if you've never used it before, is a way of performing background tasks in an ASP.NET or ASP.NET Core application. So it lets us do things like fire off individual background tasks, or if we want to do scheduled jobs, it can do that as well. But it's nice because it runs inside the same ASP.NET host as the web application. So you don't have to have like completely separate hosts and whatever to be able to do background tasks. That's something that I have to worry about, though, because if I have background tasks working in both applications, then I could have like potentially things executing twice. Next, we have the ASP.NET middleware. So this is going into the web config file and saying, like, what the heck is it doing in there? That stuff is not just easily migratable. There's no like magic right-click upgrade or migrate. And so for each one of the things I see in here, I have to figure out what is, again, the appropriate way of pulling this over. So we see here that it's doing custom errors. You can do that in the web config as well. And this is where we found in our application the sole instance of an ASPX page. So luckily, there was only one of these, and it was the 404 page. I don't know why they chose web forms to do a 404 page. They could have just done HTML. I asked them, but like the application was older than any of the people there have been. If you look at the history of that file, it predates anyone. They don't even know the name of the person that did it. Like they never heard of this person. So we don't know why it was ASPX, but it doesn't matter. That's what's there. If your application uses ASPX extensively, there is no upgrade path for you. It is a rewrite, which is a good or bad thing. Like good thing because you can finally get rid of those horrible web form pages, but there is no like very simple like migration path. Web forms do not exist in .NET 6.7 and never will exist, thank God. We do have modules and handlers, so this is the middleware plugging directly into ASP.NET and IIS. This is using a tool called Glimpse, which was a really cool tool back in the day, but does not exist anymore. It's dead. It was killed by Microsoft, so we won't have to worry about migrating that over. Dependencies. Okay, this one was another challenging thing for us to figure out. looking at all the things that our application was depending on and trying to understand what was the migration path for each one of these. There's no great tool for doing so. Microsoft has like a dependency analyzer, but it puts out such a complicated report that we found it wasn't really that useful. So we basically went one by one and said, okay, what is this something that we need to migrate over that our business logic depends on? Or is it something that is replaced by something better or different in ASP.NET Core? So one example is something like fluent validation. That is something that we wanted to continue to use, and is still supported and it is still maintained, and does have direct plugins for ASP.NET Core. So something like fluent validation.mvc5, okay, we just drop that dependency because that's the old framework, and then we can just pull in the new targeted one for the new framework. So we'd have to do this for basically all of our dependencies to understand what is the migration path for each one of these. In our real system, we did have dependencies that were not supported on .NET 6, 7 at all. Like their last release was 8 years ago or something. And so we said, okay, well, why don't we migrate that dependency first before we do any migration path to .NET 6? So when we hit these kind of roadblocks that said, there is no path forward for this thing, we said, well, let's go ahead and then migrate that to something else that is supported so that we're not changing too many things as we're doing our migration. Now, the tool we're going to be using in order to perform this migration more simply is something that came out when we were doing this analysis, like literally 2 months before we started our analysis. And this is the system.web adapters. So system.web adapters are a couple things. One is an adapter layer on top of the system.web junk to make your life easier for migrating your code. But there's also this other piece that is a self-hosted reverse proxy. And so it looks something like this. We start our application with just kind of our regular ASP.NET application that has incoming requests, hitting our application, and then talking to our business logic. Putting in the system web adapters will add this new ASP.NET Core application. So this is .NET 6, .NET 7. Now the incoming requests hit that core application. And if that core application cannot handle the request successfully, like if the controller doesn't exist or whatever, then it forwards that request through the YARP proxy, which is yet another reverse proxy. That proxy is self-hosted in this ASP.NET Core application and will transparently forward those requests to our .NET Framework application. So the .NET Framework application no longer receives direct requests from the outside world. All requests now go to this ASP.NET Core application, and then if it can handle the request, it will handle it. Otherwise, it will forward the request over to our .NET Framework application. This is what made the incremental migration 8,000 times easier than in the past. When I was doing this in .NET Core, well, just any version before this, we didn't have a self-hosted proxy, so that YARP thing didn't exist. We had instead something like Nginx sitting in front of both applications, and then every couple weeks or every sprint cycle, whatever, we'd say, okay, what are the controllers we've manual migrated this time? Gather up those different paths, and then put those into the Nginx reverse proxy one by one by one. So this gets rid of all of that craziness and just says, we'll self-host the proxy, and then it'll just magically forward those requests over. It's not magic. If it just can't handle the request, it forwards it over to the .NET Framework application, and then return the response back out to the front end through that ASP.NET Core application. Over time, oh yeah, we also have the adapters. We didn't actually use those a whole lot, but if you have a lot of business logic that's using system.web stuff, then the adapters will transparently handle, is it system.web or Microsoft.ASP.NET Core.web or whatever the new namespace is. So it'll adapt, it puts these shims in case you need those. We wind up not using those a whole lot because we did want to migrate our logic away from system.web stuff. But if your business logic is heavily tied to those HTTP context sort of things, then those adapters can make your life a little bit easier. So the plan is, we have an application that is absolutely nothing, and then over time we will migrate our controllers from the .NET Framework application over to the ASP.NET Core application. And so eventually the ASP.NET Core application becomes really large, it's eating all the controllers and removing them from the .NET Framework application. That at some point The .NET Framework application has no controllers, no pages in it. It may still have like the middleware and junk. And so once we get to the point where we've migrated all of the pages over and they're all in the ASP.NET Core application, we can safely just remove the .NET Framework application, and now we're on ASP.NET Core. So this was like, I didn't believe it when I first heard Microsoft talking about this. I'm like, there's no way it could be this easy. So let me do a quick demo of this. I'm going to switch over to come on. Okay. So let me just run this. This is an ASP.NET ASP.NET MVC5 application. Just an MVC application, nothing very exciting. It's just like file new MVC application here. And yeah, it's just kind of the stock junk here of an MVC application. This was really fast this morning, I promise. Okay, we don't actually need, oh, there we go. Is it, oh my gosh. All right, well, it's not that important to actually see this thing going. The important part is the upgrade process. So what I'll do is, I've got an extension installed in Visual Studio, and you don't have to use Visual Studio extensions to do this. There's a CLI tool that will do this for you as well. But this is the installed, the .NET Upgrade Assistant. That one right there. There, again, like I said, there's also a CLI tool that you can download that you can point it at a project, and it will do this for you. So let me go ahead and close this. And I'm going to right-click this project and say Upgrade. It's going to ask me, do I want to upgrade to a newer version, or do I want to upgrade the project features? So they're trying to build this out more and more to be able to handle more project types and more scenarios. Right now, it's pretty basic. It can handle class libraries and ASP.NET applications, but that's pretty much it. So I'll say upgrade to a new framework, and I only have one choice of what kind of upgrade? It's going to do a side-by-side incremental project upgrade, which is what I want. They did have a tool before that would try to upgrade the whole thing all at once, and it would leave you with like 10,000 compile errors. You're like, well, this isn't really helpful. And so we really want this incremental migration. Next, I want to create a new project, next, and it'll call it Upgrade Sample DevConf PL Core. I can also select the templates, MVC or Web API, so depending on kind of what kind of project you're upgrading, you can decide which template, but it doesn't matter. I can easily add more things if I want to. Next, and what is our preferred target framework? So this had .NET 7 in the title, so I'll go ahead and do that. Next week, when .NET 8 releases, then I can choose this next one. My clients, though, they typically want to stay on LTS versions, so like even though it says .NET 7, they pick .NET 6, which is fine. Our clients typically, though, pick LTS versus the STS, whatever that stands for. But yeah, exactly. Short-term support, I don't know, versus long-term support. Next. Finish, go. All right, so it's creating the project for us over there on the right. So it created that upgrade sample DevConf PL core thing. That is our new .NET 7 application. It also modified some things. Actually, no, I don't think it modified our existing .NET Framework application at all. It just did our DevConf PL core. It also modified the startup of our solution. So instead of starting just the existing .NET 4.8 application, it's going to be starting both applications because they both need to be running now in order for me to see anything on the screen. It has to hit the YARP proxy and has to go to the other one. So now let's go ahead and hit run and see what happens. Okay, so something just popped up. Bloop. What was that? Yeah, so this is the .NET, .NET Framework application. That was a .NET Core application that was running. Oh, okay. Yeah, so this is now .NET Core running, right? So it's receiving those requests. However, here at the bottom, you can see that it's proxying to. Oh, let me see if I can move that up a little bit. It's proxying to the other application, so it's the 44363. I can actually still get to that. If I want to go straight to the 44, oh, what was that? Let me just copy that. I can actually still see the older application if I want to. Like, there it is. But I really want to be looking at through the ASP.NET core host instead. So this looks exactly the same, right? There's nothing, I mean, it is the web application, but just now transparently proxying through. The existing ASP.NET core application has nothing in it. Right? It's just program CS, and that's it. There's no controllers, no nothing. It's just the basic stuff to do the middleware to proxy over, but that's all it has going on there. So I actually still can go to over here and say, let's go modify the home view, actually the shared one, go to the layout, and I'll say, oh yeah, modernizer. I remember all these things now. Where's the title? Is it at the top? Oh, that's the overall title. Okay. Right here. Oh, here we are. Right. Nope, not that. Oh gosh, here we are. Button, span, toggle navigation. Oh, here we go. This is the name right here. So I can change this. Hello, DevConf, save it, and then over in my web application, this ASP.NET Core application, then the title will be Hello DevConf. So it's still getting the updates from the underlying ASP.NET 4.8 application. So let's go look and see what's going on here in this .NET Core host. So in the project, there's not a whole lot we see here. We see that it's got an additional package reference to this core services for system web adapters, and it's also pulling over the YARP reverse proxy. So you don't have to use this like right-click doodad thing. It is just like pulling in some dependencies and then hooking up some middleware. So over here in our middleware, we have up here at the top, add system web adapters. Okay, so that's all like the system.web stuff, that'll be there. It's also adding the HTTP forwarder, so that's the reverse proxy piece, those services. And then finally in the middleware, the order is important here. It's going to say use system web adapters. So this is the piece that's going to be listening for any kind of failed request or missing like 404, 500, anything like that. Anything that's not success, this will be listening to. And when it can't do that, then it's going to forward over to the proxy2 configuration value. And it's going to be the last one. So like the last thing it'll try is to forward this over. And where does it forward over? Nothing that interesting. It's over here in my proxy2. I'd fill that in, and then my launch settings, the proxy2 value is that ASP.NET 4.5 application. So nothing, I mean, it's kind of crazy that it actually works so transparently and even works with like SignalR, HTTP2, anything like that. It will transparently forward all those things over. And my ASP.NET 4.5 application no longer receives any of those requests ever again. All right, let's keep going. Oh, that was the simple part. The rest of this talk is about all the hard parts of doing this migration. So yeah, our very first step in this process was to do an empty proxy. So what we just saw there, the file, like right-click upgrade, we wanted to do that all the way to production. So get this empty application to get it to the local build process, to their build server, CI server, packaging, deployments, and all the different environments, and make sure that our deployed environments also can handle this new .NET 7 application. There's a lot that goes into that. Like if you're running IIS, you have to install the build packs or I don't know, whatever. So to do this all the way to production does require a bit of work, but we wanted to make sure that we have some foothold first before we started migrating any of our controllers to make sure that the entire build and deployment process was all there. So once we had that all the way out, our next step was to build a shared library. Now, if you're in our existing application, this is actually following the onion architecture sort of thing. So it actually didn't have libraries already pulled out. So we didn't have to do a lot of work for this. But you may have to. If there's any logic that you want to share between these two applications, you're going to have to pull that out into some kind of shared library. And the things that we wanted to share between these two applications are basically all the business logic stuff. So none of the stuff inside the controller action itself, but all like the actual interesting stuff that was going on. So in this sample application, we're using the mediator library to basically house all of the business logic. So we already had that already separated out into different classes and different files. And so those are the things we wanted to pull out to be able to share between the different applications. So typically, this is going to be like your data models, your EF stuff, entity framework stuff. If you're using EF6, then you will want to migrate to the latest version of that because EF6 now is supported on .NET 6.7, .NET Core, so you don't have to migrate to EF Core if you don't want to, and we didn't want to yet. But this is going to be all those kind of just business logic-y classes. As well as any kind of other kind of shared business logic, services helpers, factories, whatever. Those will also be pulled out into that shared library, and basically any of that non-UI code. So ideally, we can target the .NET Standard 2.0. I won't get into a whole lot about the .NET Standard stuff, but basically we want to have a lowest common denominator of a target framework that both .NET 4.8 and .NET 7 can reference. This wasn't possible for some of our dependencies. Some of them weren't supported just didn't support .NET Standard 2.0. And so we actually had to multi-target for .NET 4.8 and .NET 7 for that library. Not a big deal, but is something that we had to figure out. So our first step was really to upgrade our dependencies to the things that actually were supported for both .NET Framework 4.8 and .NET 7. So for this application, they did a pretty good job about upgrading dependencies, but not everything if they didn't really need to. So that was our first step, was just for the existing application, before we migrated business logic, get the dependencies into a place so that we could multi-target both frameworks here. And so the final result was a single library that had all of our kind of business logic and data logic in one single spot with its dependencies upgraded to such a point where they could be referenced by both 4.8 and .NET 7. So at some point, we actually did need to migrate like the UI. And so this is a lot of kind of initial prep work just to be able to get to the point where it could pull out that code from the first controller. If we just tried to pull out that first controller, we'd have a bunch of compile errors. And so I'm trying to get to the point where it's just the UI logic that I'm migrating and not kind of all the other business logic. And so this first controller is going to be challenging to do, to say the least. You're just going to pull in like a lot of middleware. It's going to pull in things that you didn't expect were being used. Things like authentication could be pulled in at that first one. So it is one of those like I don't want to pick the controller that is the most challenging one. Some people view this as kind of like Mount Everest of like we'll do the hardest one first so that it gets through all the problems. But one of the things about Mount Everest is that it's like littered with dead bodies all the way up that are now like the waypoints of other people that tried and failed. So we don't want to treat this as like, we'll get to the summit the very first day. Instead, we'll say, well, we want to like just get to the first base camp, and that's it. And then we'll sleep, and then we'll go to the next point, and the next point, and the next point. Don't try to summit, on that very first controller. So Microsoft actually has an ability in their tooling to do this kind of like right-click upgrade migration, but it's not too good. So let's see the not too good way of doing it. So over here, I can eventually right-click. Come on. There we go. And there's a menu option, Upgrade Controller. Let's see what happens here. Upgrade. Upgrade selection. Do the thing. All right, so it upgraded the home controller, those three actions. If there was any logic being used associated with it, like if it called out to other classes, it will try to move those over as well. Ideally, that we've already pulled those out into a common place, though. And it also said, okay, I've got a couple views that I had to migrate as well. So the about view, the contact view, the index view, as well as those two kind of shared views, the layout and the view start. And so over here on the right, we now have a controllers folder and a views folder. So they got moved over now into the .NET Core application. They still exist over here, so we can go back to the old ones if we need to, but now they exist over here on the right as well. So let's look at the controller. We've got the home controller here. And if I pull up this one, okay, it looks basically the same. This is the old one. This is the new one. Old, new, old, new. Those look basically the same. This is a very dumb, simple controller, so I wouldn't expect a lot of changes. But you will see things like, oh, before you're using like I action result or something, and it will migrate that to the right type and the new stuff. The only thing else it will do is correct like namespaces. So you see up here, it used to be System Web MVC. Now it's Microsoft.ASP.NET Core MVC. Very small changes like that. Our views got migrated as well. So if I go look at my index view, like it's all there. Looks like everything pulled over just fine. So wow, we could just right-click all our controllers and it'll just work, right? No, it won't work because some things are not supported in ASP.NET Core. Look at this. It conveniently commented out things that it doesn't support. So let's run this and see how awesome it looks. Ugh. That looks like a website I would design. So what happened here? Well, the problem is that ASP.NET Core doesn't have all the features that ASP.NET has, even after all these years. And that's simply because some things are just lower on the list of things that they want to migrate over. And then some things, they're just never going to support. So up here at the top, we have bundling and minification. Those are built-in features to ASP.NET. They don't exist in ASP.NET Core. So this is one of those kind of sad things that we hit. We're like, oh, we can't just right-click these things and migrate them. For every single page we hit, we're going to run into things that are not supported or don't just get migrated automatically over. So yes, that functionality does exist, but we can't really use it. So we have to migrate all of these controllers more or less manually. But it's not that, it's not super challenging. We just basically pull over the code of one controller. We like just cut and paste it into the new application and then see what breaks. So the very first thing we noticed that broke was this is using dependency injection. And ASP.NET Core has dependency injection built in. ASP.NET 4.5 did not. So we have to figure out what is the appropriate migration path. Just first up, how do we get that controller argument to get injected correctly? So the old application was using an external container. In this case, it was using structure map. But yours might be using things like autofac or ninject or whatever the popular ones were 10 years ago, whatever. But the other thing we found is that dependency injection was kind of there in ASP.NET MVC. So it could do things like injection into controllers, but not many other places out of the box. And you had to do a lot of work to make it work kind of across the entire system and application. So this is something that will likely require like manual migration from one point to the other. We also found that it wasn't really worth trying to share this logic, so we didn't say, let's go ahead and just pull out all the common registration code in one place, because we found there was a lot of stuff inside our existing registration that was just simply working around the limitations of MVC. So most of these things we saw on the right actually just went away. We didn't need them anymore because they were just built into like services.blah. They were just out of the box for us. We also tried initially to just use the stock container, so the Microsoft extensions to dependency injection, to see can we get away with using these third-party dependency injection libraries altogether. But that may or may not be possible depending on the features you're using. So it's something we just tried initially and see how far we can get. But as soon as we hit a point where we saw, we actually do use XYZ feature, then we switched back over to like a modern version of whatever this is. Yes, so this got all pulled over into and removed. So we said, let's just get rid of all the junk we don't need. And now the only thing that's left is just the kind of business logic sort of dependency injection stuff. Everything else got moved to services.whatever. The views. Oh gosh. So this is that very sad realization like, ASP.NET Core does not support bundling and minification. And so that was used a lot in MVC5 applications. Like bundling and minification was used all over the place. And it just simply does not exist. And so MVC5 bundling lets you do things like do versioning. It can do cache busting. It can do all sorts of stuff out of the box. So we wanted to first understand, well, what is actually being used as part of this? So we could see that it's pulling in jQuery, modernizer. I don't even know what modernizer is anymore. I don't think it's even really needed these days, but whatever, it was there. As well as it was doing Bootstrap, CSS and JavaScript stuff, and and other CSS files. So when we look at the options for this, we had a few options. One was to use an open source library known as Web Optimizer. So this is a very similar bundling and minification tool to ASP.NET MVC5's built-in one, but it's not exactly the same. So it's not a one-for-one replacement. We can't just take the existing bundling code and drop it into this tool and expect it to work. The APIs are different, the way it bundles are different, and so it wasn't a just drop-in replacement. Our other option was to say, well, screw it. Let's stop using this bundling and minification stuff altogether. Let's use like a proper tool that other people use to do so. So we could go look at like a Node.js Webpack sort of thing instead. This would force us, though, to use a new tool and a new build pipeline, which may or may not be compatible with the existing libraries we're using. And it also require quite a bit of changes in the existing system and application. We also had cases where we were using some like older control libraries that also didn't support this new way of bundling. And so it is an analysis effort to figure out what is the appropriate way for us to move this bundling sort of stuff over. We wound up going with the first option with Web Optimizer because it's just, I can just do services.add Web Optimizer and then give it the different files I want to bundle together. And it can work almost the same with both applications. We did hit a problem, though, in that the bundled libraries cannot work with both applications. So our business logic, we could pull into a common library that were going to be used in both applications, but the bundles couldn't because the URLs were slightly different in each place, and we didn't want to have to go through all of the places where we're using bundles in the existing application to say, could go now use the existing use the new bundle. So instead what we did was create dual bundling pipelines where the new pages would use the new Web Optimizer bundles, but for pages that were still on ASP.NET MVC5, they would go through the proxy and use the older bundles. So those had actually different URLs and different paths for both of those different bundles. So legacy requests use the old pipeline, new requests use the new pipeline, but we wanted to make sure the static assets we didn't copy and paste in both places. So I didn't want to have the case where if I have to edit CSS or JavaScript or whatever, I didn't want to have to remember to go to two places. So we didn't want to duplicate the code. So the way we did this was, there's a way you can actually link files over where the file exists in one place on disk, and in the new C#, the new .NET 7 application, we would include those files as linked files. So when we would build and publish the application, they would actually get published over, but on disk, they didn't actually exist when we're doing local development. So over on the right, you see these little icons, it looks like a little shortcut icon. That means that the file exists somewhere else, but it's being linked over into this application. So that meant we could safely edit the file once, and it would be published with both applications. So with that solved, with dependency injection and like the view junk solved, we can now do the incremental migration of individual controllers. And the way it worked was something like this. We would copy the controller over, correct any namespaces, and then if that controller used any middleware, filters, things like that, at that point in time, we would migrate those filters over. But not necessarily before, because we wanted to make sure we still decided as we went what was appropriate to migrate. And so we would do that decision just in time as we migrated each of our different controllers over. We would copy any business logic and models over, so pull any packages needed and make sure the controller still also compiles. And then finally, copy any views over. This also may pull in shared logic as well. So if you're doing HTML helper extensions where you do like @html.blah, and that blah was something you made, then those would also have to be manually copied over and corrected. You couldn't share that logic because those are using totally different libraries behind the scenes, and so that was all copied over. And then finally, this was a bit controversial. We had to delete our MVC code. In that migration you saw earlier, where I did right-click upgrade, it still had the old controller there. The problem is if there's an error with the new controller, like any exception whatsoever, the proxy still transparently forwards the request over to the old application. So we had many pages that we thought were done and fixed, but it turns out it was still hitting the old website. We just didn't know it. So we said, okay, what we'd rather see is an error page than just like the old page, but just we didn't know it actually worked. So we would go ahead and delete the old code from the existing application once we migrated the controller over. One of the first things we hit, though, was session. This was challenging because like session is a shared state in a web farm scenario. And so the session store is not something that can be just directly used with an ASP.NET Core application. You cannot share literally the same session store between both. They have just different requirements, different structures. It's not exactly the same. But I wanted to make sure that if ASP.NET Core stored something in session, that it could be read by ASP.NET and vice versa. They could be working both places. So the way that the ASP.NET Core System Web Adapters solves this is it creates an API endpoint in your ASP.NET application /session. And then when ASP.NET Core needs to access the ASP.NET session, you will do like session.blah, but instead of doing that, it will make a behind-the-scenes API request to the ASP.NET application to get that session value, then serialize it to JSON, return it back to your application, deserialize it, and now you have that session value. That is protected by an API key, so it's not exposed to the outside world. So we want to make sure that no one can just read anyone's session there. But it allows the ASP.NET Core session to access the session state of ASP.NET for reads and writes. Configuration is something like this, where you say, okay, go ahead and add the JSON session serializer because it has to serialize that in that API call. We're going to also add a remote app server to say this is the app server for handling these requests. And finally, add session server. That was the ASP.NET MVC5. So this is now MVC5. This is hosting that app server. ASP.NET Core has a similar kind of configuration that says I need to add a remote app client calling out to that other application, and as well as adding the session client. Now the session options, there's a lot of these. I don't want to go through each one of them individually, but basically because the two session stores are different, you can either say, we'll make these work exactly the same. What we decided to do was to make them, they are very different how they work, so I don't want to just transparently say, whenever I access session, it'll just magically know which way to go. We wanted to explicitly say, when I'm accessing the old session, then I want to go through this specific path. So none of these are the greatest option for us to go for. There's going to be some limitations to each of these, and so we just have to decide what makes the most sense for our system and our application. We wind up going with this one, with the remote app session state, where I make explicit calls to the remote app, so we're very explicit about these things are over there, and these other things are then over here. So yeah, it looks something like this, where we say, I have a session manager, and when I want to get something, I will say, I'll create this session instead of me doing like HTTP context.session. And then finally, when I'm using it, it does look very similar. Like I just say session and then key value, but it is making a call out right down there to that other API to be able to get that information out. All right, so y'all asked about authentication. So this is something that we actually wanted to tackle last in our system because it is challenging to have two different authentication schemes. So I would say this is very dependent on how your authentication works. Some people are using external identity providers. Some people are doing like ASP.NET identity. So it's really, really dependent on what you're doing. You can do shared cookie auth. So if you're doing cookie authentication, just like any other kind of like web farm scenario or SSO with cookies, you can share cookie auth between those two applications. So you can sign in and sign out with the other application, but it needs to have like that certificate data protection stuff matching in both places. Or you can use remote authentication. So this is very similar to session, in which whenever you're going to authenticate or you need the authentication cookie, it will make a call out to the ASP.NET 5 application, get the cookie information, return it back, and then it will populate the claims on the ASP.NET Core application. It won't actually expose that out to the end user, that's the cookie, but in this case, instead of my ASP.NET Core application reading the cookie, it makes calls out to the ASP.NET application to get that information. So it's another I add more middleware to the ASP.NET application, and I add more middleware to the ASP.NET Core application, and then I will have my identity and principal transparently populated for me in the ASP.NET Core application. So we would do this for each of the different components in our application, all the middleware, doing this analysis of what makes the most sense to migrate over. How do we pull these pieces over? Do we replace it with something new, or do we replace it with something else? And so it was just every single thing we hit was a very targeted decision based on what the application needed and what the business needed at the time as well. So at some point, we needed to turn it off. And so the way this worked was we basically migrated everything off of the existing application with the exception of session. And so for this one, we would turn off session on the old application, turn it on in the new application, remove all the remaining controllers and endpoints in MVC5, disable remote authentication in session in ASP.NET Core, and then remove any shims for bridging over to MVC5. So at some point, we would then monitor traffic to see is the old application receiving any more traffic anymore. And once we validated that old application is not receiving any more traffic, then the last fun time was deleting all of that MVC5 code from the code base, the repository, the pipelines, and all of our deployments. So just some parting thoughts. Doing this via incremental migration is going to minimize the risk of that migration process, because we have every single controller we migrated, we deployed all the way to production as soon as we migrated it. We didn't have a big bang migration there at the end. Except for web forms. There's no way around this. You have to rewrite those pages. And so we had to decide for the web forms pages, do we migrate them first to MVC5? Or when we hit one page, do we then migrate that over to MVC, ASP.NET MVC Core? That system web adapters is magical with the YARP proxy, so if you do use that, it works really well. But there's always going to be something that is special with your application and system. I didn't even get to hang fire and SignalR, but that was a whole ball of wax of trying to migrate those two pieces. But the last just thing to leave out with is to avoid any kind of we're doing this one, why don't we go ahead and migrate all this to Node or something like that. We wanted to make sure that we avoided any kind of architectural rewrites of stuff and focused on more or less a sort of low risk lift and shift. This was really hard. We hit EF6. Should we migrate to EF Core? Well, from a business perspective, that's not going to give them many wins. They're really looking at, we want to get on Linux, we want to get on ASP.NET Core and get on all the new stack. EF6 is supported on .NET 7, so we can just migrate that after we get onto ASP.NET Core. So, thank you all very much. If you want to hear more about this, I've been blogging about this on my blog, so down there at jimmybogard.com, I've been talking all about stuff. Otherwise, I'll be hanging out afterwards for questions, and y'all have a great rest of the conference. Thank you.